Okay, here we go. We are going to start trig today. And a trig ratio, so we kind of zoom in here, and is a ratio in a right triangle that we're going to use. So when we're doing a trig ratio, the first thing we want to have is a right triangle. And then we need to make sure we understand the parts of the right triangle. The side across from the right angle is always the hypotenuse. Okay, and then let's say for a second we are looking at angle A. Okay, angle A, the side across from it is called the opposite side, and the side that is attached to it down here, this is called the adjacent side if we're looking at angle A. So let's look at another example here. If we have the same basic triangle as we had there on the left, and we have angle B up here, this is still the hypotenuse because it's across from the right angle. In this case, this side would be the opposite side, and this side right here would be adjacent to it. And it's important to know how to find the angle and to find those sides that we're talking about in order to use trig. Okay, and a lot of you probably have heard your older brothers or sisters or somebody talk about trigonometry, sine, cosine, tangent. That's actually what we're going to start looking at today. So the three basic trig ratios we're going to look at are sine, and we always abbreviate that SIN, cosine, which is COS, and tangent, which we call TAN. And the thing about these right triangles and these trig ratios is that there are relationships with the sides of a right triangle. And anytime you have an angle of a certain measure, it will always have a ratio that goes along with it in a right triangle. So let's say we have angle A, okay? And let's just forget about the diagram I drew up there for just a second. If we're talking about trying to find the sine of an angle, and anytime we have these capital letters here like this, like A, that's going to indicate an angle measure. Okay, and then we have a ratio that it will always equal. So sine, these are trig ratios you're going to want to memorize here over the next week or so, is always the opposite side over the hypotenuse. So if we have angle A and I ask what's the sine of angle A, you would find the side opposite, and that's going to be your numerator, and the hypotenuse is going to be your denominator. If we're talking about a cosine of an angle, cosine is going to be the opposite side. Okay, again, we would find angle A in our triangle. And, oh, I'm sorry, it's not opposite. I put the wrong word. The cosine of angle A, we'd find angle A. And the cosine of that angle would be the adjacent side to it over the hypotenuse. And then the third trig ratio that we'll talk about is tangent. And actually the tangent is the one that we're going to focus on today and tomorrow. And the tangent of an angle, and again an angle A, or any angle I give you on a diagram, is going to be the opposite side divided by the adjacent side. And quite often, you might have heard of this phrase before, not phrase, but this abbreviation before. It's called SOHCAHTOA, which would indicate S is the opposite over the hypotenuse. Cosine, which would be C, is the adjacent over the hypotenuse. And TOA is the tangent, which is the opposite over adjacent. And that's just another way to help you kind of remember which side lengths go with which trig ratio. We call it SOHCAHTOA. So today we're just going to start with the tangent ratio. We're going to really look at tangent today and tomorrow, so you see how to find side lengths and angle measures just with that one ratio. Okay, so the tangent ratio, as we said before, the tangent of an angle, in this case we're going to call it angle A, is going to be the side opposite of it over the side adjacent to it. And again, A is an angle, and these two are sides, or side lengths. Okay, so let's see how that actually looks. Here I have a right triangle, okay, and it says to find the tangent of S. Okay, so we want to find the tangent of S. So that means we are going to find angle S, which is right here, okay, and then we know that tangent, and I'm going to abbreviate, is opposite over adjacent. TOA. So tangent is opposite over adjacent. So the tangent of S is the side that is opposite of it. Opposite of it is 80. And adjacent to it is 18. And whenever they do these, they want you to write it as a fraction and then as a decimal, rounded to 4 places. When you do trig, anytime you do decimals, it's always 4 places. So if we put in our calculator 80 divided by 18, we get 4.4444. Okay. Then it also says to find the tangent of R. Well, here is R. So the tangent is going to be the side opposite. Opposite of it is 18. Adjacent to it is 80. And when we put 18 divided by 80 in our calculator, we get 0.225. And again, like it says down here, unless it tells you something else in the directions, always go 4 places past. And anytime it asks for a side length, we're always going to round to the nearest tenth. So let's look at this again. It's just tangent of J. All right, so here's J. The side opposite of it is 24. The side adjacent to it is 32. And remember, this 40 right here is our hypotenuse, and we do not need to use the hypotenuse when we are finding the tangent. And if we simplify 24 divided by 32, we get 0.75. And then we're going to look at, pick a different color, angle K. Here's angle K. If we want the tangent of angle K, we have opposite. The opposite of it is 32. Adjacent is this side here, which is 24. And if we put in our calculator and divide that out, we get 1.333 repeating, but we always say we're going to go 4 places past, so we'd have 1.33333. Okay, again, we're practicing with the ratio here. We have the tangent of J is opposite, which is 8, over adjacent, which is 15. And when we divide that out, we get 0.5333. And the tangent of K is going to be, here's K, opposite is 15, adjacent is 8. And when we divide that out, we get 1.875. Okay, so the idea of doing this is eventually tomorrow we'll be able to find angle measures based on just having 2 side lengths, and we'll also be able to find missing sides. So if you look at this diagram here, we have a right triangle, and we've used right triangle like Pythagorean theorem and geometric mean and all that good stuff. As it sits right now, we don't have enough information to do those, which means anytime that we have a right triangle, we can always think about if we can use trig to find a missing piece. So you are going to need to use your iPad calculator, or you're going to have to use a calculator in the room somewhere if there's calculators in there. But you have to make sure, can't stress this enough, you will get all wrong answers if this isn't done correctly. You need to make sure that your calculator is in degrees, not radians. Okay, and on your iPad calculators, you need to look and make sure in the upper left hand corner, it should say DEG. If it does not say DEG on it, That means and instead it says RAD. If it says RAD, you need to get rid of that and make sure that it's in degrees. And across the lower bottom part of the iPad calculator, there's a button that either says degrees or it says radians. But you need to make sure it says degrees in that upper left-hand corner. Okay, so with that being said, we have this right triangle, and we have a 32-degree angle, and we have the side opposite of it, and we also have the side that's adjacent to it, which means we know we can use tangent. So I can say the tangent, remember whenever we're taking the tangent of something, that's always the angle. So we're going to put 32 equals the opposite, which is 11, over the adjacent, which is x. Okay, so right now, the tangent of 32, if you put that into your calculator, is just a decimal. It's a decimal that goes on and on and on and on. Okay, so we're going to have to make sure that we're doing that correctly. So what we want to do is we need to get x all by itself. So we're not going to put anything into the calculator until we're all done. So we need to figure out how to get x by itself. Well, x is currently in the denominator, so I'm going to multiply both sides by x because I need to get x out of that denominator. It'll cancel over here, and I will have x times, leave that in blue, the tangent of 32 equals 11. Okay, remember the tangent of 32 is just a number, okay, which means we can divide it out. So I'm going to divide out the tangent of 32 from both sides. And then, so these are going to cancel, and I'm left with x equals 11 divided by the tangent of 32. Now, if you're using an iPad calculator, when you go to put the tangent in, you actually have to put 32 and then tangent. So in your calculator, you're going to want to do 11 divided by, and then we want to make sure we put parentheses around that tangent of 32. You're going to do 32 tangent, close those parentheses, and hit enter. And what you should get, if you did it correctly, and make sure you're doing these so you know how to use your calculator appropriately, what you should get is that x equals 17.6. So if you don't get that, make sure you go back and try to figure it out on your calculator to make sure that you're doing it correctly. Okay, so we have a couple more. Just going to practice the same basic idea. I have a 61-degree angle. I have a side that is opposite of it, and I have a side that is adjacent to it. So I know with opposite and adjacent, I'm going to use tangent, and I have to use the tangent of the angle. The angle is 61 equals opposite, which is 22, over adjacent, which is x. I'm just going to write this as a proportion. So remember, just like we did last time, I'm going to multiply both sides by x to get it out of the denominator. It's like a proportion. We're just doing a little cross product, basically. So I'm going to have x times the tangent of 61 equals 22. And just like before, I'm going to divide by the tangent of 61 on both sides. And I get that x equals, again, we're actually in our calculator over here, we're going to put 22 divided by, and then in parentheses, 61 tan, and hit enter. If you did it correctly, you should get that x is equal to 12.2. One thing that I should have noted before, and I did not, is that there is a tangent button. So you have a button on your calculator that says, there's a couple different things. There's one that says tan, and then right above it, it says tan -1. We want to make sure we're using tangent. And we also want to make sure that we are not using tangent with the h on the end of it. That is not till way later in math that you'll ever need that. So make sure you're just using the plain old tangent. If you hit the second, function on your calculator to get you to that tan minus 1 up there, but we don't need that. We need to make sure we're using the correct tangent button. Okay, and then we have one more over here. So we have a 56-degree angle. X is opposite of it. 13 is adjacent to it. So I'm going to say that the tangent of 56 equals x over 13. And if you notice this time, x is already in the numerator, so you are not going to have to do quite as many steps. You just need to get x all by itself. And in order to get x all by itself, we just need to multiply both sides by 13. So in our calculator, we would say 13 times, and then we're going to go 56 tan, close our parentheses and hit enter. And you should get that x equals 19.3-ish. Okay, so you can actually use these in a couple of ways here. So if we are standing so far away from a tree, we could actually, and we knew the angle of elevation. Angle of elevation is here's the bottom, how far up it goes. That would be an angle of elevation. Okay, so I'm measuring how tall the spruce tree is. I have an angle of elevation. I'm standing 45 feet from the base of the tree. So I have a 59-degree angle. The height of the tree is opposite. 45 is adjacent. So I'm going to use the tangent of 59 equals the opposite, which is h, over 45. And again, this one's nice. It's a little bit easier because all I have to do is get h by itself by multiplying both sides by 45. And if I put that into the calculator correctly, again, practice, I can't stress this enough, practice putting it into the calculator correctly. You should get that the height of the tree is approximately 74.9, where are we in feet? Feet. Doesn't do you any good to just write down what I have on my video here if you don't actually practice it on the calculator. So please make sure you're doing that. Okay, sometimes we got to sketch a little bit of a picture here. You're measuring the height of a lamppost. So let's draw ourselves a little lamppost here. There's my lamppost. I'm not a very good drawer. And you are standing 40 inches from the base. So I am standing 40 inches. And here I am. I'm standing here. That's me. You measure the angle of elevation from the ground to the top of the lamppost. So as I'm looking this way, my angle of elevation is 70 degrees. And I want to know how tall the lamppost is. Okay, so I have a 70-degree angle. My height is opposite. 40 is adjacent. So I'm going to use tangent of 70 equals opposite over adjacent. And again, this one's kind of nice because all I have to do is multiply both sides by 40. If I take 40 times the tangent of 70, I should get approximately 109.9 inches. So the height of the lamppost is approximately 109.9 inches. Okay, and then the last one here is the Americans with Disabilities Act has a law that actually states you can only have a ramp that has an angle of elevation that of at most 5 degrees, so it's not super steep. So you're designing a wheelchair ramp to enter the building that has stairs, so you need to have a wheelchair entrance. And the angle of elevation has to be 5 degrees. And I think the law is it has to be actually less than 5 degrees, but we're going to say it's going to be exactly 5 degrees. If the stairs are 3 feet high, okay, so we have stairs that are 3 feet high, and we have this angle of elevation here that is 5 degrees. Okay, how far away from the base of the stairs will the end of the ramp be? So we want to know how far from the base of the stairs to the end of the ramp. Again, here's our 5 degrees. 3 is opposite. X is adjacent. So we're going to have tangent of 5 equals opposite over adjacent. Again, our x is in the denominator this time, so I need to multiply both sides by x, and I get x times the tangent of 5 equals 3, and then I need to divide out that tangent of 5. And we should get that the ramp needs to be approximately 34.5 feet. It's in feet, right? Yep. From the base of the stairs. And your homework assignment is in Big Ideas, so you need to go ahead and complete that, please. Thank you.